One of the last thing that you have to remember from the undergraduate probability is the multiplication rule for 3 diagrams. It's a rule, when we talk about the 3 diagrams, it's a general rule, and this rule is talking about this. If we start from this point and we say that we have A1, A2, and A3 probabilities, because we have 3 events, assume we have an experiment which is giving us 3 events as an outcome. And then after the outcomes, we are conducting furthermore with another procedure which is resulting into, let's say, 4 more outcomes. And I call it B1, B2, B3, B4. So again, 4 in here, 4 in here. Now, the multiplication rule says that the probability of, let's say, event 1, 2, 3, the probability of event 3 happening is the probability value A1 multiplied by B3. In other words, if En is achieved by passing through branches Ai's, then probability of En is multiplication of the probability of the branches. Multiplicate this pi means multiplication. A1 multiplied by A2, or here A1 multiplied by B3. If, as an example, if we die, we toss a coin, and we throw a die, find the probability of having head and number 5. What is the probability of having head and number 5? What we do, we draw the tree, and the tree is in this form. At the beginning, we are tossing a coin. So what do we have? Either head or tail. What is the probability of head or tail? 1 over 2. So I write here 1 over 2, 1 over 2. After that, I am throwing a die. So it means that I have 6 values. 1, 2, 3, 4, 5, 6. Similarly, I have 6 values here. What is the probability of each of them? What is the probability of having 1, 2, 3, 4, 5, or 6? 1 over 6. So each of them is 1 over 6. Now, the question is that what is the probability of having a head and number 5? So we always start from here and we walk. So you see that we are passing through 2 branches. So P of E is equal to, what is the first probability? 1 over 2. Multiply by what is the next probability? 1 over 6. So the probability is 1 over 12. The probability of having a head and number 5 is 12. Did you get it? Now Now, what is the probability of having head and even number? Think about it. What is the probability of head and even number? So, what is the value? We have to see what are the possible way of going through head into an even number. I will erase the green line. I start from the same point. This is the way to go to the head. And this is the first even number, second even number, and third even number. So here I have three events. Let's call it E2, E4, and E6. E2 head, E4 head, and E6 head. So here what I have to do is this. The probability of events is the probability of E2 head union E4 head union E6 head. Can you tell me, Nastya, are they joint or they are mutually exclusive? They are mutually exclusive, Murtaza. If you have 2, you cannot have number 6. So this is good because it means the probability of E2 head plus probability of E4 head plus the probability of E6 head. Now, by multiplication rule, we know that what is E2 head? 1 over 2 multiplied by 1 over 6. E4 head 1 over 2 multiplied by 1 over 6. E6 head 1 over 2 multiplied by 1 over 6. So it will be 3 multiplied by 1 over 2 multiplied by 1 over 6, which will be 1 over 4. So the probability of having an even number is 1 over 4. You may need this one in order to solve one of the questions in your homework, which is available in module. Please remember, you need to register yourself for the examination, midterm examination and final examination, for image processing and also for pattern probability course. Okay. Now, if you remember, we talked about the joint probabilities. I talked about this because we need to know it in your homework. So let's continue about where we left. We talked about the joint probabilities. If you remember, we talked about the joint probability in the continuous form. We talked about joint probability in the discrete form. And we said that it's good to know the joint probability, but the issue is that how can I get the single probability from this joint probability I have? In other words, how can I get the marginal probabilities out of the joint probabilities? Now, let me write down a few of the formulas to see if you remember them. Do you remember if I have the cumulative probability, the capital F, how could I get the PDF? By finding its derivative. By finding its derivative. Now, if we have the capital F of x and y to be cumulative joint distribution function, then the joint distribution function can be calculated by f x and y of x and y is now question. If we had the fx, we would find the derivative with respect to x. Right now we have f of x and y. So what do we have to do? find the derivative with respect to x and with respect to y. How many derivatives I'm taking? 2. So this is the second derivative. So this is the second derivative. What can we say about f, x and y? It's always positive. Right? Now what does up? If I have f, x and y, how can I calculate this one? The calculator. Double integral of f. Can you tell me that what are the limits? First one, may I have an idea what should be the limits? Because it's cumulative, we start from minus infinity.
Minus infinity.
And what should be the upper limit? If I put plus infinity in both of them, what will be the result? 1. The result should be 1. Now, what about here? What do I have to put the upper limit? X and y. So this is, when I don't put x and y, there are dummy variables for the integration. Let's use u and v, and I calculate the du and dv. These are basically the two parameters that I have inside the function. Usually use x and y, but because I put them as a fixed value on the limits of integral, then I use the dv variable, the dummy variables. Now, we have to define something which is called marginal probabilities. Now, if I have the joint function, which is f, x and y, or if I have it in the cumulative form, I always get the f, x and y, so you always have f, x and y in our hand. The question is, how can I calculate f, x, and how can I calculate f, y? Can you tell me that what is the difference between f, x and f, x, y, x and y? What do you observe? What is the difference? Yes, here is y, here we don't have y. So how can I kill a variable in probability? How can I destroy y? By making it 1, right? Multiply with 1, gone. So how can I make y to be like a 1?
Integrate over y.
Yes, if I integrate over y, x, y. But what should be the limit? Minus infinity to plus infinity. Because we know that it is resembling the probability. Y is one of the random variables. So the integral from minus infinity to plus infinity should be 1. So this is how I'm getting the marginal probability for x. And I am so sure that you can guess how it will be for f, y and y, which is the integral from minus infinity to plus infinity. You tell me I write it? dx. This time I have to integrate over x. Now, we have another important rules that we need to know, and this is how we are defining this notation. Means this is how we define it. This is how we define it. And conditional probability. You remember it? Now, similar to this, we have, if we have the condition here, we divide the joint probability over the marginal probability. Over the marginal probability. And it's very obvious that what can we say about f, y, and y? We know that if x and y is greater or equal than 0, what about f, y, and y? It cannot be equal to 0 because we have the division by 0. So it should be restricted greater than 0. It should be restricted greater than 0. Why we need this definition? Then we can define the bias rule. So in the joint probability, we talk about the bias rules. And it says f y given x of y given x is f of x given y of x given y multiplied by f of y divided by. Now, divided by, in the bottom part, if you remember, we had the summation or the integral of the probabilities. Here, similarly, we have the integral of the probabilities of f x given y, x given, let's say u, f y of u du from minus infinity to plus infinity. Then we get back to this formula in example later. But if we didn't have a joint probability, if we said that given x and y is statistically independent, if you remember, we had now, if this is a joint probability, we will turn this in this form. In other words, when I'm calculating marginal probabilities, I am giving you, in a question, we have, let's say, the cumulative joint distribution function, or we have the joint distribution function. The question is, are x and y independent? In order to find if they are independent or not, you have to calculate the marginal probability for x, for y, and then you multiply fxx by fyy. If it is equal to fx and y, then you say that x and y are statistically independent. Otherwise, they are not independent. Let's do an example so you understand all these formulations, how you can use it. Given f x and y of x and y to be when x is between 1 and 3 and y is between 2 and find A, fxx, and fyy. Good. I'll do the first part, which is easy, and then I'll ask you to continue with the rest. First part is finding A. We know this rule. This is equal to? This is equal to? 1. This is equal to 1. From minus infinity to plus infinity, the integral of the distribution function is 1. This is the fundamental rule. Right? The addition of all the probabilities is equal to 1. In the continuous form, the integral of all the probabilities is equal to 1. Now, this question is a good question because we know that x is defined for a limited value, y is defined for a limited value, right? And otherwise it is 0. In other words, I don't need to have integral from minus infinity to plus infinity. Now, tell me which integral, Nastia, which integral do you want to take first, x or y? In other words, there are double integral. Do you want to have this one as x or this one as an x? This one as an x. So x is changing from 1 to 3. This one y is changing from 2 to 4. Now, here, as you can see, x and y are between two solid numbers. They are not depending on value-wise on each other. But sometimes you can say that it is between 2, let's say, and x. Then the order of the integral cannot be changed. What is the function between 1 and 3 and 2 and 4? A, x, y. Now, what do I have to write here? No, because the first integral that I see is y, so it will be dy dx. So this is something that you have to recall from the double integral. This is dy. If you change, you put here the x ones and other one, the y values, then it will be dx dy. Now, let's calculate the integrals. I want to review it so you will remember it better, because we need to use it later again. Now, let's find this integral. Integral from 2 to 4 ax y dy. Now, a is a constant, so it comes out of the integral. What about the x? Is x a constant?
Yes.
Yes, with respect to y, it's a constant, it gets out. Y dy. If you remember, I wrote the formula for you on the previous session. What is the integral of y dy? It's 1 over 2 y squared from 2 to 4. So it will be ax multiplied by 1 over 2, 4 to power 2 minus 1 over 2, 2 to power 2, which is 60 minus 4 is 12 multiplied by 1 over 2, it's 6. So it will be 6ax. Please check the numbers and values. I can make a mistake. So, I know this inner integral. This is 6ax. Now I'm coming to the bigger integral. the upper one, which is from 1 to 3, 6ax dx. And I know that this is equal to 1. You know that this result is equal to 1. So I calculate this integral, 6a comes out, it's constant. This will be 6a multiplied by 1 over 2x squared from 1 to 3, which will be, should be 1. It will be 3a multiplied by 9 minus 1, which is 8. This is equal to 1. So from here, a is equal to 1 over 24. You get that a is 1 over 24. Now, you remember the formula, right? The formulation of x dx is, because the power is 1, it is 1 over, or let's put even n here, it will be 1 over n plus 1 multiplied by x power n plus 1. Here, n in this case, or in this case, n is 1, so I have 1 over 1 plus 1, which is 2. Multiplied by x over 1 to the power of 2. Did you get the number 1 over 24? Now, I want you to calculate f, x, and x. How can I calculate f, x, and x? We just wrote it. Marginal probability of f, x. X is the integral of this one with respect to the dy from minus infinity to plus infinity. Why I solved the first one for you, so you know that here a is 1 over 24. So you have your f, x, and y defined. You have f, x, and y defined. May I erase this part? So, f(x) and x is integral from minus infinity to plus infinity f x and y dy. This was the definition, but definition is not always the case. Why? Can you tell me that where the y is defined? I know y is always 0 except if I am between 2 to 4. So this will turn into a very pretty formula of an integral from 2 to 4. What is f, x, and y? 1 over 24 x, y, dy, which is x over 24 integral 2 to 4 of y dy. This is x over 24 multiplied by y squared over 2 from 2 to 4 for y, which is x over 24 multiplied by 16 over 2 minus 4 over 2. But let's even put it in this form. 2 to the power 4 minus 2 to the power 2. We should know that 16 minus 4 is 12 divided by 2 is 6. 6 multiplied by x over 24, it will be x over 4. In other words, my f, x, and x is simply x over 4. X over 4. Any question on this part? So if you face a question like this, you can solve it, right? Now, and the next part is asking, can you read this one? What is this? Exactly, it's CDF of y. It asks for finding the CDF of y. There are two ways of finding the CDF of y. One of them is calculate the marginal probability for y. Calculate the marginal probability for y. And then integrate it from minus infinity to the value of y. Integrate it from minus infinity to value of y, which is asked. I can write the integral of 3 because I need to. What is the marginal? What is the marginal probability of y? What is this? This is marginal probability of y, which is the PDF of y, right? Now, CDF is integral of this one. So I should have an integral from minus infinity, because here I have the value y, but I don't want this y and this y to be confused. That's why that here I put, let's say, the value v dv. Do you understand what happened? This is a dummy variable, y, v, whatever you want to put it. Because I want to calculate this constant from minus infinity to that value of the marginal probability of y. So you see, I have a double integral now. Let's calculate the first integral. Let's call it. What is this integral? From minus infinity to plus infinity, what can we say about the joint? Yes, it's been from 1 to 3, because the rest is 0. 1 over xy over 24. Now, because I am using v here, the variable y will be v of dx. So it will be v over 24 integral from 1 to 3 of x dx, which is v over 24 x squared over 2 from 1 to 3, which is v over 24 multiplied by 1 over 2 multiplied by 3 to the power 2 minus 1 to the power 2, and this is 8 divided by 4, so it will be v over 6. And then f y of y is integral from minus infinity to value y of v over 6 dv. Okay, what about this integral? What about this integral?
1 over 2 y power 2 minus.
Now, what can we say about the v? V is y, right? V is always 0 except if it is between 2 and 4. So here we have to define it in this form. Can I erase this part? Now, please stop writing. Look at here, because this is something that we have to be careful with slightly. I want to find f, y, and I know that this is the integral from minus infinity to y v over 6 dv. Up to here there is no problem. But the question is this. What is the value of y? If y is less than 2, if y is less than 2, what is happening? Yes, there is only 0 because it doesn't exist. If y between 2 and 4. What is happening? From minus infinity to 2 is 0. So I will have the integral from 2 to y v over 6 dv. Can you tell me what will happen? What will happen if y is greater than 4? It will be 1. Why? Because I'm covering all this. Afterwards it's 0. I don't add anything. I have the addition of the whole probability. So when y is greater than 4, it will be 1. So we need to calculate this simple one, which is integral 2 to y v over 6 dv. So it will be 1 over 6 multiplied by 1 over 2 v squared from 2 to y. And it will be 1 over 12 multiplied by y squared minus 4. Y squared minus 4. Are you correct? Are you correct? Yes, you are correct. Now, so this one is 1 over 12 y squared minus 4. Now, my friends, just one question. The CDF, this is CDF, right? The CDF is a continuous function. Let's see what will happen if I put 2. I know that 2 is 0. It should be also 0 in here. I put 2 instead of y. 4 minus 4, 0. It's done. This is 12. Right? So it means that there is a joint here. If I draw the PDF, the CDF for y, if this is y and this is fy, before till 2, everything is 0. No problem. Now, the other issue is when I am at 4. When I am at 4, it says that the value should be 1. Right? I am checking in here. I put it instead of by 4, it will be 16 minus 4. 12 multiplied by 1 over 12, so it is 1. So this is also okay. And if we connect it, it will be something like this. So this is the CDF. So always, in order to check if you are right or not, check for these boundary conditions. They have to be satisfied. For y over 2 is 0, here it should go to 0. For y greater than 4 is 1, it means that for y is 4 is also should be 1. Yes, you have a question?
What happened to the 4 in the second integral? Yeah.
4?
Yes.
No. Y starts from 2. Y starts from 2 till the value y. Y is less than 4, but what is it? We don't know.
Or maybe it's 4.
Maybe it's 4. We put 4.
It's equal to 4.
Maybe. We don't know. The value of y is between 2 and 4. Now, what is the value of y here?
2 or less than.
We don't know. It's a value less than 2. But we know that the result will be 0 because the function, the value of the function is 0. Here, what is the value of y? We don't know. We know the limit. But in the integral, the upper limit is y. Y will be maximum 4. In the reality, how much the value of y? We don't know. And in this case, what is the value of y? We don't know. But we know it's greater than 4. So here the integral is actually something like this. From 2 to 4 v over 6 dv. Y, we put 4 here because we know that we should put y. But we know y only till 4 is defined. Afterwards it's 0. That's why we keep it 4. Here, we don't know what is the value and it is defined. That's why we keep value 1. Now,
another question. In the first one, we put the y less than or equal to, and again
here, do you know why? What is it? What? And Nasir can answer this question really well. What is the probability of a point? 0. Probability of y is equal to 2 is 0. So, you don't like it, don't put it anywhere. Put it everywhere. Put it only in one of them. As you like it. Probability of a point, what is 0? Now, I solve one thing for me. And it is, are x and y in this example statistically independent or not? Why? What is the marginal probability of x? We calculated it. X over 4. What about y? Did you calculate it? Yes. They are statistically independent because you already have calculated it. Where did you calculate it? With y. Help me with my writing. Okay, it's b over 6, which is y over 6. Y over 6 multiplied by x over 4, it will be 1 over 24xy. But also, if I am giving you directly this one, if I directly tell you that fy is this, can you tell me what is f if this is given Morteza? Can you tell me that what is the marginal probability? If I give you this, can you tell me that what it is?
Yes.
How?
By differentiating.
Yes, we just find the derivative of fy over y. And you know this is 0. This is 0 constant. This derivative will be 1 over 12 multiplied by 2y minus 4 is 0, which is y over 6 already. Because we look at we find the derivative of the region that x and y are defined. If x and y are 0 or constant, we don't care. Okay, write down the solution. Okay. Let me erase everything now. We want to talk about something new. We want to talk about something which is called expected value. So the topic is expected value and moments. Let's define the expected value. Expected value of random variables. Please excuse me for the short form writing, right? Expected value of random variables is defined as weighted sum of the random variables in which the weights are probabilities of random variables. Probabilities of random variables. In other words, for a discrete random variable, E of x, we show it in this form. E of x is defined as summation of xi multiplied by p of x is equal to xi. value is defined in this form. And in the continuous form, E of x is defined as integral of x f fx. Of course, from minus infinity plus infinity. Before I get back to this equation, I want you to define also the moment that I will get back and I tell you that what they really represent. Then ice moment of the ice moment is defined as expected value of x to the power I. This is called the ice moment. First moment, this is the first moment. Second moment is I is 2 and so on. So what is expected value of xi? For the discrete and for the continuous. For the discrete one, can you tell me what it is? Look at the definition. If it is x, we have this one. So it will be the summation of j's, xj to the power I. P of x is equal to xj. And in the continuous form, it is the integral of x to the power I f xx dx. Now, expected value. Expected value means what you are expecting to see. If we have the first moment, okay, finish writing. If we have the first moment, in other words, the power of x here is 1. Can you tell me that what do we expect to see if you have lots of random variables? Okay, if you have lots of random variables, we do an exam for 100 students. So we have 100 random variables because the students are random variables. And a student can get a number from 0 to 100, let's say. So 100 random variables, because the grades are also random variables. So we can define the grades to be random variables. Random variable 0, random variable 1, random variable up to, let's say 0 is not possible from 1 to 100, so we have 100, okay? If I tell you that within this class, we have 70 students who got 60. 70 students got 60. And I tell you that I randomly pick one of the students. What do you expect to see the grade of the student? 60. Right? But if I tell you that now, be more precise, I am picking up one of these random variables. What is the expected value that you see? Will be the average of all the values, right? Because in high probability, the student that we pick up will have the average value. This is what we are expecting to see. We are expecting to see one of the average grade, because if I know that what is the average of the class, in high probability, if I pick one, it will be within the average. Now, this is when I'm talking about the first moment. So, first moment means the weighted sum of the random variables, which means that is what I am expecting to see. So it is representing the mean. So it is representing the mean of random variables. Don't we have to divide it by total number of our elements?
If it is probability, no.
Yes, it is probably no. Why? Because the weights are already normalized. What is the definition of the mean? Definition of the mu x is this, right? Is the summation of fi xi divided by summation of fi, where fi is the frequency. How many x do we have? 5 of them. How many of that? We have hundreds of them. Which is, we know that I can write it as f1 x1 divided by summation of fi plus f2 divided by summation of fi x2 and so on. What is this one? Probability of x is equal to this one multiplied by x1 plus the rest. So already that division is in the probability. So the first moment or the expected value, we call it expected value, is equal to mu x. Is equal to mu x. The moment of x to the power I is the expected value for x to the power I. Is the expected value of x to the power I. Now I want to define something else. I want to define something else. And it is variance of x, I put the curly bracket, which we show it as sigma squared this is the definition of variance. This is the definition of the variance, which means in the discrete form, let's consider the discrete form, it will be, so variance of x, because this is the expected value of x minus mu squared, it's the summation of xi minus mu squared multiplied by probability of x is equal to xi. This was the definition of the variance. But what is important for us is this formula that I'm just writing it. This is very important formula. The variance of x is defined, sigma x squared is defined. Expected value of x squared. What is this? This is the second moment. Because I is 2. So this is the second moment. Minus expected value of x squared. What is this? Expected value mean. So it will be second moment minus the mean square. It gives us the variance. It will give us the variance. And we know that sigma squared is always positive, so it's very clear to see that ex squared will be greater than ex squared. And when we have the moments, we represent it by m, so this is mi. So I can write it as is m2 minus m1 squared. m2 minus m1 squared. We don't go to the proof of what expected value is. For discrete random variable, expected value of gx is this. You can easily make it integral to see for the continuous form. For discrete joined random variables, that means that we have two variables, x and y. This is let's have one of them j. What will happen if it is continuous? What is that? Which integral?
Both x and y.
What are the boundaries?
Minus infinity plus
What do I have to write here?
fxy.
fxy dx dy or dy dx. Now, expected value is important because by using expected value, as you can see, we can calculate the variance, we can calculate the mean, we can define the moments, we can define something which is called correlation coefficient, which we will talk about it on tomorrow's lecture. The expected value is important because we can use it in order to find out the orthogonality of the random variables. Now we can solve an example regarding to this expected value. In the first homework, we don't have any question regarding to the expected value, as you can check. So tomorrow we will continue regarding to our calculation of expected values and correlation. Any question? If you have no questions, then not the lecture for today. Yeah.